So let's get going here. Let me find my presentation. So share my screen out and find what I'm going to look at here and open that up. Okay, hopefully everybody can see the little presentation up there. So tonight we're going to talk about duplexers and diplexers. It's a little bit of a techie type of a discussion here, but there's actually some cool things that'll come out of that and help you understand how you can use a duplexer, some good ideas as far as what you might want to do in the future with duplexers and what's the difference between a duplexer and a diplexer. So things that we're going to end up knocking off this evening is what's the difference between a duplexer and a diplexer. Hopefully everybody will come up with a good understanding of that. Okay, this is not a discussion about something that you put on the back end of your printer to be able to print two sides of a piece of paper. So we're not talking about printers in this discussion. We're going to be talking about AM radio. So we're going to talk about when do we use a duplexer or a diplexer, selecting the right device, purchasing a duplexer or a diplexer. And so you know, this subject, I'm only covering just the very, very top level of stuff. The discussion on duplexers and diplexers, I could go on for an entire evening on all the things that that involve in selecting and using different kinds of devices. Okay, so it's also common where people will interchange using the word duplexer or diplexer. People have a tendency to swap things around and it can get really, really confusing. So hopefully this discussion, things will become a little more clear with everybody. Technically, there is a very distinct difference between the two devices. And I want to make sure everybody gets that. Okay, and if you select the wrong device for the wrong reasons and you put it in place and you use it, you can end up causing a lot of destruction and kind of destroying your transceiver there. It's bad news if you grab the wrong device and use it in the wrong way. So let's start off here with a little explanation. So we're going to kind of talk about what kind of problems you can solve with selecting one of these devices. So here I have a very simple use of it, and this is probably the most common, probably what you're going to end up doing if you want to use one of these devices, where you have two antennas outside. Let's say one's a 2 meter, one's a 440 antenna. And you want to take a single piece of coax coming out of your transceiver and be able to connect to these two antennas. In other words, your transceiver is a VHF, UHF dual band transceiver, and you want to connect to both of these two antennas. Well, kind of tricky because you got to match each one of those things for 50 ohms. What you can do is use a duplexer in there and then connect up your 2 meter antenna to a 2 meter input on it. You can connect your 440 antenna to your 440 input on it. And this little device will steer the RF to the correct antenna. So if you're transmitting and receiving on 2 meters, this little duplexer will steer all that information going to your 2 meter antenna. And the same is true on your 440. Now, what I've used this for is that I have a couple beams up on my tower that one of them's a 2 meter beam, one's a 440 beam. And rather than having to run two big old honking pieces of very expensive coax going up to that, up in top of my tower there, right between the two beams, I have this duplexer. And each one connects to the appropriate antenna. And then I have one piece of coax that comes back down to my transceiver. Very nice fit, and it works absolutely great. And there's a lot of good reasons for doing things like that. So that's going to probably be your most common reason to do something like this. So here's one that's a little bit weirder. Let's say you've gone out maybe and bought a 2-meter transceiver, and then later on you buy a 440 transceiver. So now what I want to do is connect up to an antenna, and I just happen to have a really nice GP6 or GP9 a ground plane antenna, which will handle, that one antenna will handle both the 2 meters and the 440. So again, I can take a duplexer, I can take one transceiver, connect up with one port, and another transceiver for the 440 and connect up to the bottom port there. And then I can talk to that antenna. That duplexer will direct the receive and transmit for whatever receiver onto that coax. So the neat thing is that we know if we take 2 transmitters and tie together and put an antenna out there, we transmit on one, the chances are we're going to blow the snot out of the receiver on the other transceiver. So the important thing that this guy does for us, it provides isolation. It will provide isolation. So the 2-meter transceiver does not get to see anything going on with the 440, nor does the 440 transceiver get to see anything going on with the 2-meter. Very important, very important. If you didn't have that kind of isolation, again, you would let the smoke out of your transceiver, very expensive transceiver. So here's another really cool one, just a moment, where this is a good application for field day. So generally at field day, I drag out a very nice tri-bander for HF and put it up on a 40-foot tower, and I get to operate it the whole time. So I wanted to show you a way that you can actually have multiple operators. And typically on a field day, we have one person assigned for 220 or for 2 meters, another one for 15, and another one for 10 meters. This year, you may get some action out of. There has been some action on 15, and almost I'd say over half the days this past month, we've had some action on 10 meters. So this is a little device that's actually called a triplexer. It allows you to connect 3 transceivers to one HF multiband antenna. And in this example, I have 20 meters, 15 and 10 meters that you can have individual stations out there. They make triplexers that are actually quadplexers, where you can actually have 4 different stations connected to one particular antenna. But a very cool solution for field day where you can have multiple guys using a big high-powered antenna that has elevation and has directionality and that has good solid gain to it. So something that we might want to consider in the future. In fact, for big contest stations where you have multiple guys, you know, where you have a 200-foot tower with multiple Yagis stacked on the tower, they'll use a device like this. So they'll have one station on 20, another one on 15, 10, blah, 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 like that. And they'll use a device to keep everybody separate. And so this device, again, it has the ability to provide a good high level of isolation to make sure one transceiver is not interfering with the other transceiver. Okay, so this is the one that we're probably most acquainted with, and this is something we use on virtually all of our repeaters. And this is a kind of a high-end duplexer, and there's some special names that we use for this type of duplexer. So this allows you to have one antenna out there and have 2 repeaters that are not only working within one band, and it's very important to note that these guys are working within one band, and you can see that in this example it's working in 440, in the 440 band. So this means that you have a transmitter that is transmitting at the same time that you're receiving. That receiver is on the same band as the transmitter, but there's an offset. There may be an offset of 5, 10, 15, 20, 40 megahertz. Very, very small offset. So this duplexer has very steep, very severe bandpass filters in it that will only let, like the receiver will not see what's going on with the transmitter, even though it's right next to it, transmitting on the same piece of aluminum out there, but that receiver is not going to be able to see what's happening on that transmitter. And you can see from this example, there's not a whole lot of difference between the two frequencies. There's only 5 megahertz between the two, between the transmit and receive. Really, really narrow. So this is a really high class, high end duplexer. We'll get into what that looks like. Okay, so this time we're gonna go from, rather than the easiest to the hardest, we're gonna start with the hardest and then move to the easiest and the simple one. So we're gonna talk about this high-end duplexer. So normally it's a 3-port device that allows transmitting and receiving to use a single antenna at the same time on similar frequencies. Not within different bands, but within similar frequencies within a band. It has a really high level of isolation to make sure that the transmitter does not interfere with the receiver. And remember, this guy is sharing a common antenna up there. It's not a separate antenna. And even if you had separate antennas, they would be so close, you would still have to have the same concept in there to keep those guys apart. So this guy is also sometimes referred to as a circulator, typically used in a repeater. So it's used to separate receive and transmit frequencies within a band. So you saw that, it's only 5 megahertz apart, which, those are next door neighbors. So anytime you put any type of a filter into a transmit or receive system, you always have some kind of losses. So this kind of filter will typically get you between 1 to 2, maybe a little bit more dB worth of loss. Not too bad for what it has to do. The really amazing thing is that the isolation between the transmit and receive, you got almost 90 dB or greater amount of isolation, huge amount of isolation. So that receiver will never see what's going on with that transmitter, and that's what you have to do. This type of duplexer, it can be sized to handle higher power. So it's just bigger. It's a bigger duplexer. You just throw more money at it to make all of this stuff work. So here's a couple pictures of it. Up in the upper left-hand corner, this is a 440 set of cans for a repeater duplexer. This little device over in the right-hand corner there is actually an impedance matcher. So that's the transmit side that goes into it. On the left-hand corner of this is the receive connection. You can see that those are pins were 440. Those are UHF type of connectors. And right here in the middle, that's where the transmitter and receiver come together and feed the common antenna. The picture down here in the bottom left is a set of cans here. This is a 2-meter repeater. The one off over here to the right is actually not for 2 meters, but they make them for this. This is just a low-cost duplexer. Does similar things, but can't really handle the power. Does not have anywhere near the level of isolation, thereby it limits the power. But this is one that can be easily used for a 5 to 25 watt repeater system and make it work. And like these little guys here, they'll run between probably $200 to $300 for that. These other, the bigger ones for VHF, UHF on the left side of the page there, those are going to run you into the thousands of dollars. Another really neat type of duplexer. This is a type of duplexer that allows you to transmit and receive from two radios at the same time into a dual band antenna. Got to get your head around that one there. It's a lot of words. Okay, it's made from a pair of bandpass filters, one for each band. Bandpass filters must provide high level of isolation. So let's go down to the bottom here of this little picture. So this little light blue box that represents the duplexer there. So you can see on the left side there, you can have a transmit and receiver operating through a filter. And note, the big difference here is that these guys are working on different bands. One's a UHF, the other one's a VHF band, two different bands. Huge difference in frequencies. It just so happens you have a real nice antenna up there that is able to support both VHF and UHF. On the right side of the picture, you can see you have another transmitter receiver operating through a really nice bandpass filter through on the UHF band. And again, these guys are built where these filters are built where you have a pretty darn good level of isolation between this. So the UHF transmitter does not interfere with the VHF receiver. Typically, these are run on a little on lower power. You'll see these guys good for anywhere from 5 to 25 watts. So this particular guy has an insertion loss of about 0.2 dB. You're going to end up having more losses going through your connectors than you will from the actual duplexer in there. Isolation between the transmit and receive the different bands is going to be somewhere between 40 to 45 dB. So it's not anywhere near like we'd get with the big cans that you use in a repeater. It can handle, generally they're made to handle low and medium power. They can be upsized, but when you upsize something with that number of components and how it has to get put together, size starts climbing. You can get these guys here for anywhere from, probably I'd say about 50 to 100, 120 bucks, pretty inexpensive. So here's some pictures. Here's three different duplexers here. The one on the upper left here, that's a pretty name brand one, good, been around for a long time. I'm going to talk a little bit about the MFJ, and then here's what's called a triplexer, and we'll talk a little bit about how this guy is made up. So first of all, stamped on the outside here, you can see you have a common port. Now that common port may go to an antenna or it may go to your transceiver. This guy doesn't really care what direction the electrons flow, it's all the same to him. The port here on the lower left, you can see that's good from 1.3 megahertz to 2.25. So this covers all of the HF bands, 6 meters, 2 meters, and it claims it handles 220. We'll talk about that in a moment. This other port on the right side here, it handles everything up in the 440 band. It also gives you power ratings. So if you're operating in the, so on the left side, you can either hang your HF antennas or a 2-meter antenna on it. The right side there, you can hang a 440 antenna on that. So I was getting ready to mention that here it also shows you what you have for power ratings. So you can run up to 500 watts through this. I wouldn't do that. I just when you tear it apart, it's nice and compact, good stout components, but I have problems seeing that you could want to be able to put 500 watts on it. The other thing you really have to think about on these devices, if you have an antenna out there that doesn't have a particularly good SWR, that SWR, that high voltage is going to get reflected all the way back down through this unit until it gets back to your rig or to a tuner to be able to tune that out. So that high SWR is likely to carry a lot of high voltage and can cause problems with it. So this combination here on the bottom here, as far as frequencies for each one of these ports or channels, that's pretty common on how they do things these days. So let's talk about the good old MFJ one. So one of the things, I watched a really good YouTube video on it, and I'll just give you the high points so you don't have to watch the whole thing, because took this guy and ran it through a VNA vector network analyzer. We had a recent discussion about that, and we took a look at its performance. It did pretty nice as far as impedance. Impedance was right where it should be. The losses were pretty darn close to what it was, but one of the things they found here is that if you wanted to use this for 220, it wouldn't do it. It won't pass 220 signals. It'll pass 2 meters just fine, but it cuts off just before the 2 meter band. So this guy here from MFJ, if you wanted to use it on the 2 meter band, wouldn't hack it. The other interesting thing, the isolation, I think this one was spec'd at about 40 to 45 dB worth of isolation. On the 2 meter band, this guy gave you about 78 dB worth of isolation, so that was a nice surprise. But the minimum amount of isolation all the way across was at least 40 dB, which is what it was spec'd for. But we all know what to expect from MFJ. I'll just say it. They're usually fairly close, but they're not exactly right on their specs. So this is a triplexer. Sorry, the focus isn't real great on this, but this is a cool unit where if you wanted to, this could connect back to your transmitter. You have down here on the bottom here, these are just chunks of coax that comes out that has PL259s on it. The leftmost port, that takes care of all your HF through 6 meters. Middle one takes care of your 2 meter stuff. The one on the upper right, or the right side, that takes care of all 440. So one of the things that is kind of interesting, I've seen people to try and keep their coax costs down. You know, when you deal with LMR 400, that can be some pretty expensive coax. So they'll just run one piece of coax out of their shack. They have another duplexer back in their shack to pick up their, to use your 220 and 2 meters is all combined on one PL259 out the back of your rig. And then you have a separate connection for your HF. They'll run it into a duplexer out there, run a single piece of coax out to under their roof or someplace, and then they break it out from the coax using a triplexer so they can get HF and all your VHF and UHF connections out of it. I've never done that. I know you can do it, and I hear people have done it. I just haven't run across anybody that has done it. But just food for thought. You might need it someday for some particular reason. So let's hit a diplexer. Diplexer is a little change in things, but we'll see what the main difference is. Okay, a diplexer is, again, 3-port device that allows you to connect 2 different antennas to a single piece of coax. And there's a little diagram there. And inside the diplexer, you have two filters in there. And the one filter passes the information, for 2 meters to one side, and the other one passes everything to the 70 centimeter side. So these consist of 2 filters, one low pass filter, one high pass filter, and obviously at different frequencies to steer things. These do not employ a band pass filter. So means that there's no band pass filter there. You will not have any rejection factor between the A and the B side of that filter. So if you try transmitting, like where I have the antenna 2, if you try transmitting into that, you're not going to have the kind of rejection. If you have a separate receiver out here on the 70 centimeter side, it's going to end up potentially getting RF back into it, which could be detrimental to it. So it just doesn't have any real rejection to it. It's a low profile, low cost, very simple um, diplexer that can connect coax to multiple antennas. And these guys here are run probably between $28 to $50, pretty inexpensive. Okay, so the filters are good for simple or for simplex, so you can't multiplex stuff through there. For simplex, transmit and receive. No real isolation between channels. Other configurations, you know, you may have one port that's set for AF, the other port is set for VHF, UHF. So you can buy them in different configuration. And yes, there are also triplexers in this type of combination. Okay, so we're going to wrap things up here, and I got a couple of review slides here to see, make sure that we can kind of make sure we understand what's going on. Think of a diplexer as a simple way to connect two antennas to a piece of coax. The pros on it is that it's low cost, made from simple high-low pass filters. The con is that there's no isolation in this. So it's cheap, inexpensive, but it gets the job done. Duplexer. So we know that there's different kinds of duplexers out there, and this last discussion, I'm not going to be talking about the ones that we use at the repeater level because quite frankly, that's way out of my pocketbook range. Good for connecting multiple transceivers to one antenna. Handles two or more transmitters transmitting at the same time. So if you have two or more transmitters transmitting at the same time, it'll handle that. And that means you have to have the combination VHF, UHF, excuse me. And can be used to connect one coax to multiple antennas. So it's a little bit of a Smith Army knife as far as a Swiss Army knife as far as all the things it can do there. So duplexers, reasonable cost is probably between 40 to 100 bucks, can handle a higher power. You just throw more money at it. Good isolation between channels. Has really low insertion loss. That's the cool thing about it. And the other thing you want to remember is that if you have bad SWR out of your antenna, it's only going to come along and it's going to stress the heck out of your duplexer, and you may end up letting the smoke out of it. So that's it, folks. Let me know if you got any. Stop the sharing there. So back to you guys, and if you have any questions on any of this stuff. Too complicated? So Bill, what do you think?
Good.
Yeah, Bill, what do you think of that? The idea of using one of those higher end 3-channel duplexers for connecting up to that tri-bander that I put up and having multiple stations out there.
Yeah, that could be real interesting. I thought you used something similar to that already for yourself.
No, not like that. Not anything like that. So I just not on a beam like that. It's always been one transceiver connected to it, driving the whole thing. The only thing that we did was like with Matt, we put a VHF UHF antenna up on top that he ran.
Oh yeah, and that was, I remember. Yeah, that was it. Yeah, that might be a real interesting goodie to purchase for next year's field day.
Yep. And I bet even Drew would
save $300 not going to city campground this year.
Yep. And that would actually interest probably Drew a bit as far as getting on there to be able to also operate one of the other bands with the higher antenna. I know Ted has that that hex beam over there. It's multi-banded. So with one of those devices, we could also use other bands on that hex beam. So just other ideas. Any other cool questions?
That was really interesting. I'd gotten a couple of these devices sometime back in the past. I never really understood the difference, so I appreciate this.
Okay. And you can see how it obviously saves. It can save coax for VHF, UHF for my two big Yagis up there. It really makes a nice connection to make all that stuff work with one piece of coax. Because Yagis, when you have a Yagi, they do not make dual band Yagis. You either have a 2-meter Yagi or it's a 440 Yagi, or it might be 220. But it's either one or the other. The size difference is huge. And so if you have two vertically polarized Yagis up there, you can't get it on the same mask. You end up having two separate antennas, and a duplexer just solves that problem so nicely. Now, a lot of those duplexers, most of those things are not watertight. So you would need to put that into a watertight enclosure. So at least it can all drain from the bottom out. Otherwise, if you don't put it in a watertight type enclosure, you'll be replacing it by the end of sometime during the winter. Okay, I think I'm done. Back to you there, Anthony. Anything else?
Thanks, Mike.
Thank you.
All right. That is our meeting for June. Hope to see everybody back in July. Be the same bat time on the same bat channel. Yeah, everybody have a good field day. And if you can, we'll look forward to getting the coordination details from Bill.
I'll shoot that
So yeah.
you can put it on the mail list.
All right.
Thanks a lot.
And right now, while we're talking, I'm working a guy in North Carolina on FT8 on 10 meters.
Anthony, there's a lot of good presentations here, and I haven't been able to see all of them. If someone could possibly put these presentations on the PRA webpage, it would be very nice to be able to go back and take a look at them. My first one was back at the Walton Lake presentation, and I thought that was very nice, but I missed a number of them since then. Is it possible to do that?
So right now we have the recording for the presentation from last month, and we'll have the recording for this month. Yeah, my plan is to get those uploaded here. Again, I have my local phone company put in some brand new fiber to my door a while back, and didn't tell anybody until I was poking around. I'm like, there's a new box out here. What's that for? And sure enough, I have a pigtail of fiber hanging out next to my house. I'm like, so when can you hook that up? And they're like, how about on the 20 whatever? I'm like, all right. Let's get some internet out here, because my 3 meg DSL line can not keep up. So yeah, hopefully by early next week I will be able to get both of those uploaded, and again I'll shoot that information out to the emails, and hopefully with we'll be able to get kind of consolidated. I know that's one of the things I was looking at was we have a long list of email addresses of everybody that's been a member at one point or another, and then we have the Google groups. And so I'm hoping that we can get everybody kind of consolidated into one system here shortly, and not have to send out 2 sets. But when I will send out an email once I get the videos uploaded and have the bandwidth to do so. So we will get those up. And then as far as previous ones, I'll have to reach out. I think Jim might have recorded some. So I'll have to check with him and see what he might have had, and see if we can get some of those uploaded, and see what we can cobble together from everything. So.
Good seeing y'all.
Good seeing
Yeah.
everybody. I'm going to get out of here and I'm going to get some dinner. So catch you guys later. And
All right.
happy
Hey,
hunting
all right.
on some
Bye, everyone.
DX.
Agree.
Okay.